There we go. Transition. Good. Okay. Okay, so here's going over of this part of homework. Some people, I would do a number line. Number line is start at here, 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 or here. Sorry, start at this point. 1, 2, 3, 4, 4 points. And I'll do a number line test based on that. I'm gonna get going. Is it positive? So it's positive here. Is it negative? So it's negative here. Is it positive? So it's positive here, and negative is below.
I thought you told us we can't do endpoints.
Endpoint, no. Endpoint, critical point can be endpoint, but a rule theorem cannot be endpoints. A mean value theorem cannot be endpoints. So critical value can be endpoints. Also, this is second derivative. The second derivative is gonna go, if you look at the function, it's gonna go up. So it's gonna be positive, it's gonna go down. It's negative, is positive, it's going to positive. If negative, it's going down like this. So you look at the slope of it. Basically, you will have a 4 critical point here because long as f prime of x equal to 0, they are part of the critical point. It doesn't matter with critical point. Critical point does not matter. Only mean value theorem cannot be the endpoints. X equal to -3, x equal to 4. Basically, they're changing from positive to negative. See how they cross the x-axis right here? They're changing from positive to negative. So therefore, you got a relative max. And x equal to 1 is going to be only one is relative min. Are you guys following me so far? And then you have, just read the number line, just write down those information. You're supposed to write a union. That means one interval and another interval. And x equal to -4, x equal to -1, x equal to 2. That means f double prime changing in sign, or f prime of x changing from increasing to decreasing at x equal to -2, x equal to 2, or decreasing to increasing at x equal to -1. Does everybody follow me so far?
Yeah.
It's good so far?
Yeah.
Okay, so now some people is asking this part. Is this part an inflection point? I'm gonna prove to you they are inflection point. How am I gonna prove it? I'm gonna use the decimals. I'm gonna create a functions. So this is a function I created. It's an x squared when x is greater than 0, and the negative x squared when x is less than 0. Now, if I take a derivative of both functions, I get 2x and -2x. And you see that it's a cusp, it's a sharp turn. However, in the first function, original function, is still an inflection point. You see that concavity change at 0, so it's fine. If you take a derivative again based on the sharp turn, that's where you have a 2 horizontal line. One is at +2, one is at -2. Okay, that's what's gonna happen. So it's not continuous in terms of derivative of that functions. But yeah, it's okay. So I just proved to you that they can be at x equal to 2. Now, from -5 to 4, -4 is concave up. From -1 to 2 is concave up. From -4 to -1 is concave down. 2 to 5 is concave down, based on my number line. So if you do your number line correctly, you're going to do great. You're going to have a whole test question about this, and you're going to have to figure out what to do with it, okay? And it's going to be an easy part of the test. On AP exam, that's going to take account around 6 points. I'm going to show you that. So this is the question that takes around 6 points. So I'm going to cross out certain things. I'm just going to do it from the beginning. So I'm going to delete this part, but I'm just going to do so you're supposed to cross out this information here, those information extra. Those are for part D of the question. This is actual AP exam question from 2013. And you say, how easy to earn points on AP exam? They are not that hard. Especially this question, good 4 to 6 point, easily point for you. So how do I get it? So those 2 points here. Find all x coordinate with relative maximum. well, the relative maximum, if I did my number line correctly, it happened at x equal to -2. All you gotta do is write down x equal to -2 here. And then you got 1 point. And then they say, give me a reason. That means justification. Justification, you're gonna say it's f prime of x change. Not f of x, but it's f prime of x changing from positive to negative. You got a second point. +2 right here. Easy 2 point. Now the problem of the second one, there are 2 intervals. Most of you guys only got 1 interval. There was a reason why. Now I will draw this number line on the scale. Do you see that -2 is right here? And do you see that -1's right here? Right after that. So -1 and 2. So when I draw the second number line right here underneath, when I start at -1, I make sure it's after -2. And this one is on 1. So this is on the same line as 1. And this one is going to be 3 and 4. Now why is that important? Because they say f has to be both concave down and decreasing. So there has to be fit both criteria at the same time. Both criteria here is concave down, which is f double prime of x is less than 0, and f prime of x is less than 0, which is both a negative. Now if you pay attention, that there is a part that here is negative here, right? But it's also negative here. There's overlap. Do you see this region here?
Yes.
It was -2 to -1. So it'd be -2 to -1, and that is a parenthesis.
Oh, and this is open.
Dang, that's pretty smart. I wish I had that smart.
So in here, I will see that it's going from 1 to 3. And give me a reason that's going to be f prime of x is less than 0 and f double prime of x is less than 0 at those intervals. That's how you get all the points here.
You just said they're both negative. Is that the same
So
thing?
it's -2, -1.
-2 to -1,
I wanted to-
and a 1 to 3. And that's how you get both points. So you're gonna get 2 points, and you got maybe this one is worth 5 points here. I don't know. I don't know the scale scoring guideline. I think it's this 2013. I'm not sure, but you can go look at scoring guideline to get this. So you can minimum get 4 points already at here if you draw your number line correctly. But both line is the best as on scale with each other. So that way you can compare both things at the same time. Now find the x coordinate for all point inflection. Now here it's just gonna be -1, 1, 3. So x equal to -1, x equal to 1, x equal to 3, because that's when they change sign. So you can say f double prime of x changing signs at those values, like changing sign at those values.
Can you say that f prime is 0 at these values?
F double prime is equal to 0 does not mean that they have changing concavity, because you could have positive to positive. So you could have positive, 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 then you have no inflection points at all. In this case, you got negative to positive is an inflection point. Positive to negative is another inflection point. Negative to positive, you got another inflection point. So those 3 points of inflections. Questions? Okay. Now this is the first derivative test. All you guys know how to do this. The first derivative test is f prime of x is equal to, so I have these functions right here. The first thing is I want to take a derivative. And now I'll go ahead and find out the critical value. In this case, it's going to be -1, 0, and 1. I will plug in all the things. Now remember, -15x squared, I will plug in as a negative. Why? Because x squared is always positive. -15 always negative. So negative times positive is always negative throughout the whole way. I'll plug in x squared minus 1, and now do a number line test, and that's how I get positive, negative, negative, positive here. And that's pretty much switch out the sign to negative to positive, positive, negative. So it's going to be decreasing, increasing, increasing, decreasing. You will have a min because you got negative to positive. You will have a max because you got positive to negative. So you got those 2 points. And you got 0 is neither. 0 does not fulfill with the maximum minimum because you went positive, positive.
So the minimum's at 1, right?
At negative 1.
Negative 1.
And maximum is at 1. You might have similar questions on the test. I will ask you to prove a second derivative. Guess what? Take the critical number. It's not that hard. Take the critical number on the first derivative, plug into the second derivative, and see what kind of value am I getting. So I'm plugging -1, 0, and 1, and plug into the second derivative. Of course, you have to find the second derivative, which is you do a derivative of that. Power rule. You're going to get from one point to the other point. Fairly easy. Then just plug in -1. See what happens. Remember, if it's a positive, if the value you get is a positive, which is like this, concave up, and then you have a thing, it's like a Karate Kid, like a paint the fence, right? So if you have paint the fence in this situation, guess what? If you have concave up, which is positive, 30 is positive, then you have a min. And if you have a concave down, then you will have a max. Okay, so that kind of tells you that reconfirm with the first derivative test. Remember, first derivative test tells you where's the maximum and minimum. Second derivative test tells you where's the maximum and minimum. But use a different approach. One is to look at the concavity, one is to look at the number line test of increasing and decreasing. First derivative is going to tell you increasing, decreasing. First derivative test is going to tell you where's the maximum and min. So there is a small slight difference there. Okay? Am I going too fast? No? Okay, we're going to keep on going. Woo! This one's going to be fun.
Sure.
So what I'm going to do is I'm going to start from the very scratch. Okay, I very scratch. Now I did the number line test. Based on those information, I do my number line test. Because from here to here, I'll have a negative. And you see this negative between 0 to 1. Do you see that? Mm-hmm. And if you see here is a positive between 1 to 6. Mm-hmm. And between 6 to 8 is negative below x-axis. Between 8 to infinity, 8 to whatever, 9 is a positive. So I did my first part of the number line test. And I'm going to do the second part of the number line test here. So I'm going to say, I'm going to write down this is up. So this is up. And this part is down. 2 and 3, -2. Oh, no, sorry, 2 and 3. So 2 and 3. And this part is down. And this is up. And this is down. And this is up. Okay, so why? Because this one is a positive slope all the way to 2. Negative, positive, and negative, and positive. Am I going too fast?
No.
Okay. So this part is easy. Decreasing. Decreasing is going to be between 0 to 1 according to the number line. And the union 6 to 8. And you got this, you say, oh, okay, that's easy. We got this. Local maximum. Is any local maximum here?
Yes.
Max is at where?
Which one's that?
Is that 6?
6. And where else?
No.
Nope, only not 6.
Yeah.
And the min at where?
1 and 8.
X equal to 1 and 8. So this one is a min. And this one is a max, right? So x equal to 8. So this is going to be f prime of x. Change from negative to positive. I'm going to just write down shorthand. You're not supposed to do that. You're supposed to write down the word so you can go to the credit. So f prime of x, I don't have time. Change from positive to negative. Okay, so that would be the easiest way for me to do. I'll write in sentence form and just make sure I get all the credit. Concave up. it's going to be 0 to 2, 3 to 5, 7 to 9. Union, union. Inflection point, x equal to 2, x equal to 3, x equal to 5, x equal to 7, I think. Okay. Justify. How do you justify this? This is going to be f double prime of x is
Equal to 0.
greater than 0. Sorry, it's greater than 0.
Oh, I think I'm pretty-
This one is f double prime of x changing sign. You have to have a sign change in order to have inflection points. At x equal to 2, x equal to 3, x equal to 5, and x equal to 7. So you have to change in sign from negative to positive. You have to have a sign change. Now we're going to talk about the last part. The last part is the part that you have to incorporate everything, and that's what we're going to talk about, a curve sketching. A curve sketching is very, very hard for a lot of you guys if you don't have a systematic approach. We're going to talk about a systematic approach here. So I'm going to use a number line. I'm not going to erase the number line. I'm just going to do a lines here.
What a coincidence.
It's mad.
And if you have 0, 0, I'm going to have a 0, 0 here. That should have give you one specific point there, but understand that's called an initial condition. Later on, you're going to learn that word in a second when we talk about integrals. That's the initial conditions. Now, the function is going to follow the first number line. So we're going to look at this number line, and we're going to go according to that. So first of all, label all those.
Hey, Robert did it too.
Okay, so no, I'm going to draw in a dotted line here to show me my points. So from here to here, it's going to be decreasing. And after 1, it's going to be increasing all the way to 6. So 6 is right here. And then going to go decreasing again. And till 8 and then 9. Like this. So if you have something like this, it's a very, very good. Now for me, I draw a smile face on the maximum and min, or sad face. So here is going to be a happy face, sad face, happy face. Now I'm going to show you the second trick. The second trick is to do the inflection point. The inflection point occur at 2, 3, 5, and 7. So at 2, I'm going to draw a cross. 3, I'm going to draw a cross. 5, I'm going to draw a cross. 7, I'm going to draw a cross. Every time I go through a cross, I'm going to have a concavity change. So I'm going to draw in the graph like now. And the first time I'm going to show you how to do practice, I'm going to just use a highlighter. So it's concave up. Then after that, I have to specifically change the concavity of the graph. Concave down. Concave up. Concave down. Concave up. And that's going to be the graph is going to be. So I'm going to show you on black. Concave up, concave down because there was a concavity change, concave up, concave down, concave up. Now, on AP exam, they're not going to ask this question, fortunately. However, I will ask you on my test because on calculus in college, it's going to have asked this type of question, not unlike AP exam. The reason I think they stay away from curve sketching is because the rubrics. It's really hard to grade those type of questions. If a student a little bit change, it's really hard to justify how to get the points. So for them, I don't think they stay away after 1990s because in 1990 they still give you a graph that you have to sketch from with non-calculated sections. Am I going too fast? No? Okay. So what we're going to do is we're going to talk about this graph and we're going to do a curve sketching on this. Now where's the function? The function is going to be x times x minus 4 to the third power. So
So, where? Oh, I see. So, what do we call this? Page?
we're going to call it curve sketching. Curve sketching is we're going to say something out of blue here. And we have a to the third power here. Now, the one thing I will tell students is you start from the basic information, from Algebra 1. Algebra 1 is going to tell me x-intercept and y-intercept. Those are very, very basic information. Algebra 2 is going to tell you vertical asymptotes, even horizontal asymptotes. But I'm not going to worry about those code sketching. In UCF tests, you're going to see those. I don't know anywhere else, you're going to see it. But UCF, you're going to see that part. But if you pass this exam, then you don't have to worry about UCF. But you have to pass with a 5 if you want to become an engineer. If you want a business major, you can pass 3 or 4. So on AP exam, so Robert is like, I'm business major. Okay, business major, that's fine. You can pass with 3 or 4. Then by then, they're going to ask you to take something called business calc. And business calc is a lot easier if you know how to take simple derivative. You don't even know how to do chain rule. You can just simple derivative, it should be good enough. So what I would do is I would do x-intercepts and y-intercept on the original function. How do I find x-intercept? Well, you plug in 0 for y, right? For f of x. We do that for one critical numbers. And you're gonna find two zeros here. And y-intercept, you're gonna plug in 0 for x and solve for y. And then you're gonna find out one of the points is gonna be repeated, and that's gonna be easy. So here we got 0 equal to x times x minus 4. X-intercept, so x is equal to 0, x equal to 4. Does that make sense?
So we just ignore the cube?
We can put a q there. I forgot. So I can also plug in 0 here to find out 0 times 0 minus 4 to the third. That's 0. So basically you got x-intercept is at 0, 0, which is also known as a y-intercept at the same time, because 0, 0 is both. And the x-intercept also has another point, which is 4, 0. Are we okay here? So that's just basic information that I can very, very easy to extract. Now, second things I want you to extract is f prime of x. Can you guys take a derivative here and make sure everybody on the same track to take a derivative correctly?
Chain rule, well, no, what's our product rule?
Product rule and chain rule, yes. What does number 5 mean?
Wait, 0 in for y, is that, that's 64, negative 64?
What?
Well, we don't really.
0 in for y? Or for
Uh,
x, I mean?
The derivative
Like, for
of,
define the
of x is
y-intercepts?
1. So you know, what about 4x minus
0 times anything is 0.
Oh,
That's basically power rule.
Yep.
Basically power rule.
I think there's 2 x-intercepts, 1 at 0, 0, and then 1 at 4, 0.
Yeah, but 0, 0 could be y-intercept too, so they're the same point.
Yeah,
Basil, what's the number 5 mean?
but we don't need to.
I don't know, Ferris. What's the problem? We have your stream.
See the
going
problem
on,
with
we wanna
your
watch
stream.
it. Well, I wasn't looking for text that.
Gotta hope the viewership is that. Get on the stream.
What do you have as the instance?
Make sure you factor out GCF while you're at it.
Wait, do you want to solve for x or just do?
I want you to take a derivative and factor out as much as you can, GCF.
Oh, okay.
So first one has a product rule and chain rule. Don't forget, there are 2 functions here.
I got the derivatives, now what I do.
So if I take a derivative of x is 1, right? And that's going to be x minus 4 to the third plus x times 3 times x minus 4 to the second times 1. And I can factor out x minus 4 to the second. If I do that, I'm going to get x minus 4 and plus 3x. So that's equal to x minus 4 to the second times 4x minus 4. I can even factor out 4 is like this.
Well, wait,
I don't have to, but I factor out GCF. Anything GCF I can see, I factor out.
So it's x minus 4 cubed?
Square.
X minus 4 squared. With this one, I can do a number line test.
I did 3 now.
At 1 and at 4, I'm going to do x minus 4 squared and the x minus 1. So I here it's going to be positive all the way through because it's something square. It's not square minus 4. It's something squared, and you obviously square everything. And then if you plug in 0, that is going to give you a negative. If we plug in 3, it's positive, 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 negative. Decreasing, increasing, increasing.
Let's do yeah.
Robert, can you like stop being tall?
Like at the 3x.
Inflection point, I don't know if it's at 1, but you got a decreasing, increasing. That's probably a relative min
Can we tall again? Thank you.
because that's a first derivative. Can you figure out at 1 what would be the coordinates? So 1, if I plug in 1, what am I going to get? Negative 27, I believe. And those are very, very important points. So we did that already.
Let's do yeah.
I'm gonna poke someone's eye out.
For the derivative, like,
Just like you poked
Zoom
someone's
back
eye
in.
out yesterday.
Sure.
Paper airplane.
so this is 1, and then x is plus x times 3,
What?
plus x 3, and then x minus 4 squared. And
X minus 4 plus 3x. Yeah.
Well, like, do you multiply those two? Do you distribute the x?
You factor it out. X
No,
minus
like
4
at
squared.
the first part.
I factor out x minus 4.
Yeah, I did too. Squared. And then.
So it's just going to be 3x on the right.
Oh, that's not really good.
No, okay, well, why do you factor out the 4 on the right side if it didn't go on the left?
I factor out 4 because I like the GCF outside. Now I'm going to go into the second derivative. Second derivative is going to be like this, f double prime x. And then I have to do a product rule again, so that's okay. That's not too bad. It doesn't have negative exponents, so it's fine. So I'm going to take it down to 2. I'm just going to bracket here because I'm going to take out a 4 completely and just take derivative inside. So 2 times x minus 4 to the 1 times x minus 1 plus x minus 4 squared times 1. Bracket. I take out 4 completely, so I just take a derivative, whatever those two factor is. So I think it's going to be 4, and then now I'm going to factor out something here. What do they have in common? X minus 4 in common. And then that's left with the 2 times x minus 1 plus x minus 4, I believe. And that's equal to 4 times x minus 4 times 2x minus 2 plus x minus 4. And that's going to be 4x minus 4 times 3x minus 6. Can I factor out GCF? I think 3. I think that way. Now this question, of course, is a little bit more difficult, but your homework is going to be relative easier. So here it's going to be 2 and 4. And I'm going to do x minus 4 here, and then x minus 2 here. So it's going to be 0, so it's going to be negative, negative, positive. 3 is going to be negative, positive, negative, positive, 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 up, down, up. So inflection point at 2.
Yeah.
If I plug in 2, 2 minus 4 is negative 2 to the third power is negative 8 times 2, negative 16. So that's an inflection point. And at 4, we don't need a plug-in on that one. We already know 4 is 0. That's also inflection point and x-intercept at the same time. We got everything we need. We got relative min, we got 2 inflection point. We're just gonna go do the curve sketching. Now curve sketching is not that difficult. You just have to take a couple try, and you only have 2 questions on this today. And you know, it's not something that is, I'm not giving you something like super difficult, but 2 questions on this. But your graph is gonna look at something like that, but we're gonna start from the middle. So I'm gonna delete this, I'm gonna delete this. Now I'm gonna use this to help me, is those are the x-intercepts, minimum, inflection points. So I'm gonna use that to graph. Draw a nice straight line. Okay, each one I'm gonna use 2 as a thing. So 2 for all the way to 10, and 2, 3, 4, 5 is negative 20. 1, 2, 3, 4, 5, negative 30. So hopefully that's enough. So 0, 0,
Yeah. On the top left.
1, 2, 3, 4. This is a 0. Negative 1. Alright, 1 is going to be negative 27, so roughly 26 here. 27. It's going to be a minimum. I draw a smile face. At 2, negative 16 is going to give you a cross. And then there's a cross here.
Where's the other like 4-0 point?
4 zeros right here. But it's also a
Yeah.
cross.
But like, where's the point from?
The 4 zeros is x-intercept. And also as well as a thing. As well as other things. So now I'm just going to graph the increasing, decreasing. So I'm going to go back to look at number lines. I start with the decreasing all the way to 1. So decreasing all the way to 1. Like something like this. Now I'm going to follow the concavity after I do the sketch. The sketch is going to be in red, so I'm going to do it use the highlighters first. So it's going to be concave, it's going to be concave. Concave up, concave down, concave up, like this. So I'm going to use the black marker now to draw it. Oh, red marker, sorry. And then after that cross mark, I'm gonna change it from concave up to concave down. And after that, I'm gonna change it up like this. And this is my graph.
So yeah.
Line through a curve.
Why is it like?
Those are concavity changes.
Why is it like negative x? Like the top part.
This part,
Yeah.
yeah, there's a negative because they still have negative number in there, but it's decreasing, so it's have to be above and in order to decreasing.
Okay.
There's no restriction on the interval, yeah. There was no restriction from negative infinity to positive infinity. So in this case, in order decreasing has to be above to go into the zeros.
Thanks for another great Titan day.
Wow, perfect timing.
Students,
Could you
you
zoom
are
in on the
now
graph a little
dismissed.
bit?
Sure.
Is that negative 20? Oh.
And if you have a question, go watch the stream. Subscribe, click like, comment.
When you're finding the inflection point, you're trying to find
Yeah, because I need to plug in the graph.
No, yeah. But like, you solve the,
and then I
for the y value by plugging
Original function. Yeah.
inflection points at 2 and 4.
Okay.
What?
Okay, there.
I haven't make an intro yet. I'm gonna make an intro. I already have intro on my other computer, but I'm gonna bring it to this computer. But I have it overlaid now. It looks good.
See you on that.